like 2 minutes when
I said 5. See, that's better than what I said.
okay. Just know how to put it in. But today's even better than yesterday.
Sweet.
Because today I'm going to show you how to do derivatives without a calculator and without using the limit definition. Like big day in calculus because we're going to learn like the basic rules of how to do derivatives, how you're going to do derivatives for the rest of your life. All right? How to find derivatives analytically more efficiently. The rest of your life. When you're 50, this is how you slowly find derivatives. All right, I just got lots of rules for you here. The constant rule. The derivative of a constant function is, what if I had a function like y equals 3? What's the slope of that line?
0? No, yeah. 0.
Y equals negative 10. What's the slope of that line?
Also 0.
So it's a line like this, right? Its slope is 0. Derivative is the slope of a curve. So the derivative of a constant function is always 0. So this means if c is a real number, right? I like to give you lots of math speak here. If c is a real number, then the derivative of c is 0. And that's an easy one because you can just think about it. Just like a linear function, we already know. Okay, ready for me to blow your mind?
That's going to be a good blow your mind.
Yeah, it's going to be like, oh my gosh, I've been wasting all this time doing limits.
That's okay. I didn't really understand that.
You can't forget limits. Because of a test. Chapter 3 test, you will have 2 problems that you have to do with. Alright, so I'm going to give you the derivative of this, and I want you to look at the pattern, okay? So we just talked about this. What would the derivative of 1 be?
0.
0. The derivative of x, what would be the slope of the linear equation x? It's 1. The slope of x squared, the derivative of x squared is 2x. The derivative of x cubed, 3x squared. And we've done this all with limits. So the derivative of x to the 4th.
4x to the 3rd.
So what do you notice, Grady?
Well, it's increasing by 1, the constant is, and the x is also increasing by 1.
So what if I gave you x to the 50th?
49x. Oh, wait. Yeah, 50x to the 49.
So explain to me the rule using this instead of saying it's going up by 1.
Well, the power is always the constant.
The power you bring down front and it becomes the coefficient.
Then you subtract 1 and put it in front.
And you subtract 1 from the exponent, and that's the exact thing you would get from doing the limit definition of a derivative.
Why?
Isn't that exciting? This is called the power rule. Probably the most important rule of derivatives. So notice the if part of this. If n is a rational number, then the function f of x equals x to the n is differentiable, and the derivative, of x to the n is always bring the power down front, so that's n,
X.
and then times x to the n minus 1. Okay. Now I can give you lots more problems to do because we can do derivatives a lot faster. Okay, ready? Oh, we just did x to the 4th, but that's okay. I think we should practice using notation. You can use dy dx. I'm a big fan of f prime of x. Right? You want to show that you found the derivative. No more limit definition when you know these rules. Because you just do the power rule. And you tell me if I need to show more work in this. But the 4 comes down, and then x to the 4 minus 1 is 4x to the 3rd. Right, so what if it doesn't seem like it's written as exponent? So you have to think about, my rule that I know is x to a power. So if it's not x to a power, use your algebra skills to write the square root of x as x to a power. Yeah, so that's the same as saying h of x equals x to the 1/2. So the derivative power rule, bring the 1/2 down front, and then you subtract 1 from the exponent. So Grady, you're exactly right. 1/2 minus 1 is x to the negative 1/2. And it's kind of up to you on how you do this, or if it's an odd problem, I really want you to check the back of the book and see how they write it. Sometimes in calculus, we say, we've done enough calculus, we don't need to simplify negative exponents. And sometimes they simplify negative exponents, and you just need to be okay doing either one. So, on this, I think we could simplify this pretty easily. How do we simplify a negative exponent?
Put it in the bottom.
Put it in the bottom. So, like, we could write this as 1/2 times the square root of x. That would be the same. If you check the back of the book and they leave it as a negative exponent, then leave it as a negative exponent.
Then do we rationalize the denominator?
No, we're not rationalizing the denominator. No. In calculus, we say we know how to do it, we're not doing it.
That's pretty tight, I kind of do it there.
And again, if the back of the book rationalized it, then I would rationalize it. So this is kind of preparing you for the multiple choice of being able to match answers, all right? What about on this one? Can I do the power rule yet on this?
Yes.
I can just do it right now?
Yeah, just x to the 6.
Oh yeah, you have to write it as just x to a power, so that you can bring up and make it x to the negative 2. So I'm going to call this y prime, since it's written as y. Right, if you say y equals and not y prime, like that's really incorrect, because that's not what y equals, it's what the derivative equals, so really practice doing that. So if I bring the negative 2 down, what is my new exponent going to become?
Negative 3.
Because I'm subtracting the negative.
This is all I'm listening to. You have to really happy.
It's most of it.
Okay.
And again, you can do it like that, or that's also the same as negative 2 over x to the 3rd. Alright, the rest of it, I just have some more rules of how we can make things a little more complicated, but really the same thing. So, it's getting a little more exciting. Constant multiple rule says, if f is a differentiable function, and c is a real number, then c times f is also differentiable. And basically, if there's a constant in front, you just kind of ignore the constant and do the derivative and then simplify. And we'll talk in a minute about how you'll probably just put it all together at once. But basically, if there's a number in front of an x, you just leave that number alone and then take the derivative.
Just slap it in front of it.
And then multiply. I'll show you in a minute. Like I'll show you on number 4, like writing it out, and then you can talk about, well, I probably won't do that. I'll just jump straight to the answer. But basically, if I have f of x equals 3x to the 7th, the 3 doesn't change the power rule. So you can just ignore the 3, and how would you take the derivative of x to the 7th? So you'd say times 7x to the 6th. But do you think I want you to leave your answer as 3 times 7x to the 6th? No, which means
You know how to do it, we're just not going to.
21x to the 6th. So maybe, how could you make a better rule than just saying leave the constant alone, do the derivative?
Multiply the stuff.
Yeah, so when I do these, I normally say I bring the 7 down, so 3 times 7, and I automatically write 21. If it helps you to write it out, especially at first, this is day 1 of this, then write it out. But you're going to have to simplify it. So how would I write number 5 before I take the derivative?
10 over.
Yeah.
10x to the 0. Just 1 minus 0. 1, 0.
Why are you subtracting 0?
Subtracting 1.
What's negative 1 minus 1?
Oh, you give me the answer. You just move it up.
Right, you have to move it up before you can subtract 1, right? So you have to write it as a power first. So if I bring the negative 1 down, are you okay if I just write that as negative 10? And then subtract 1 is negative 2. And again, this one's not bad to simplify. So I'm going to move it to the bottom. What about this one? Do I need to move the 6 up? I tried to trick you on this. Yeah. Like that's just, right? Like that's just 5, 6, x. The x can go on top or not. And so using the power rule, like I gave you that, you could just think about the slope here, but just to show you, if you wanted to see that the power rule does work on this, if you leave the 5/6 alone, right, that's really like x to the 1, so then that would be times 1, and then 1 minus 1 gives you x to the 0, and so that's why it's just 5/6. But you don't have to do that. You can just say, oh, it's linear, the slope is 5/6.
Wait, but like if you plug in a number for x, wouldn't 5 times x all over 6 be different than 5/6 times x?
Nope.
Are you sure?
Promise.
Check 5.
Think about this. 5/6 times 5 is the same as 5 times 5 over 6. Either way, you get 25/6. Okay, how do you feel so far? Overjoyed, super excited about calculus now?
Like I'm just about to tear us down.
No, I'm not.
Like a
One more thing. What if I throw in addition subtraction? Nothing really changes except for the problems get longer. So the sum or difference of two differentiable functions is differentiable, and it's just the sum or difference of the derivatives, which means you just take the squares of each term in the sum or difference. So the derivative of f of x plus or minus g of x is just f prime of x plus or minus g prime of x. My father-in-law and my husband's brother, both when they sneeze, it's like minimum 10 sneezes. Like they start sneezing and they get up and they leave the room because it's just like over and over again. Very weird. My father-in-law is not the father of my brother-in-law, but they both do the same sneezing thing. That's weird, right?
I didn't actually, so fast.
Yeah, they do like 10 of those. Like out of control.
My dad sees a lot too, and Joey does too. It's just like, Joey, get your crap together. I'm not blessing you anymore. Like,
I'm not blessing you
bless you 3
anymore.
times. That's enough.
So do you understand what that means? Like how you can take the derivative of this now? You're just going to do the derivative plus the derivative minus the derivative plus the derivative. It's like 4 derivatives in one. Think about doing that with the limit definition. That would have been a lot of work, right? Are you ready for your test today? Are you just not doing your homework?
X squared plus 4x minus 1.
It's the review to prepare for the test.
What's one doing in study hall? You got a test today.
All right, what is it?
2x squared.
3x squared, right? Bring the 3 out front.
Just for the next variable.
3x squared.
Plus 4x.
Bring the 2 down, so 2 times 2 is 4, and 2 minus 1 is x. Minus 1, because that's just slope of 1, or you can think about bring the 1 down and x to the 0, and then what's the derivative of 7? 0, something like that. So this
That's it, that's your answer.
is my derivative.
I really don't like you right now for not telling us this until now.
The limit?
Use the limit thing on the AP exam?
So you're not going to do the limit thing, but it'll show up as like a multiple choice question. Does that make sense? Like,
I'm not going to do it, but it's going to be on the test.
Like, it could be a multiple choice question that says find the limit as h approaches 0 of 2 plus h minus, no, f of 2 plus h minus f of 2 all over h. And they'll give you some function, like it could be a terrible function. We'll pick a really easy function, like 3x squared. And they want you to recognize that that's a derivative. Like that's saying find the derivative at x equals 2. So that's what shows up on the AP test, is they want you to recognize, oh, that means derivative. And then you can do the shortcut to say, well, the derivative of this is just 6x. They're asking me to find the derivative at 2. Oh, the answer's 12, and then you circle 12 and you move on. But that's why, 1, you have to know this. And 2, if I just showed you these rules on day 1, you wouldn't understand what we're actually doing. You wouldn't understand that we're using secant lines to get to the tangent line, and you wouldn't understand that idea of getting closer and closer to it until it actually comes to it. Well, some people do. 1/5 x to the 4th. I feel like you're going to get really good at, multiplying, subtracting 1. You're going to get really good at doing that. So I bring that 4 down, so that's 4/5. And then that would be x to the 3rd minus 28x. Grady, you're the only one giving answers.
I'm never stepping out. Then I get less points.
How do you feel about that?
Leave less points.
I was so stressed about getting through this. I'm like, we're almost done already. Out of control.
Whoa.
All right. We talked about this. You're going to see the same types of questions that we've already done. Write the equation for the tangent line. Does the curve have any horizontal tangents? Or where does the slope equal 7? But now you can use the shortcuts to find derivatives, which makes our life a lot easier. And it makes us able to do a lot more complicated functions. So does the curve have any horizontal tangents? What does that mean, horizontal tangents? We know it has a horizontal tangent when there's a max or a min, yes? In terms of derivative, what would the derivative be of a horizontal tangent? Yeah, a horizontal line would have a slope of 0. But instead of slope, we're going to say a derivative of 0. So this is like saying, does this function derivative ever equal 0? All right, so another big part of calculus is understanding what the question's asking, knowing the words to change into what am I supposed to be doing. So we're not plugging in 0 for x here. We're going to find the derivative and set the derivative equal to 0. So now we can find the derivative very easily, hopefully very easily. So, Katie, you give me the first one. What is the derivative of x to the 4th?
4x.
Jacob, you're up next. What's the derivative of the second term?
Minus 16x.
Minus 16x. Alex, what's the derivative of 2?
2. Right?
No, it's a constant, right? The derivative of a constant function is 0, right?
Yeah.
Yeah, so it's 0.
So it's just 0?
Yeah. So if you have a constant in, its derivative is 0. So I think that's my derivative. Do you concur with me?
Yes.
If it said find the derivative at x equals something, now we plug x, the value in for x, we get the slope. But this one says, does it have any horizontal tangents? Which means we set this equal to 0. And we solve it. And we solve that.
Add 16x.
Terrible idea.
We pull out the x and then
I'm going to pull out the 4 and the x. Are you okay with that? Is that factoring in 4x times x squared minus 4?
Oh. Look at the difference in squares.
So I get 4x equals 0 and x squared minus 4 equals 0. So you're right. X squared minus 4 is a difference of 2 squares, and you could solve it that way. You also could just add 4 and take the square root. Either way, you should get plus or minus 2. Which means that this graph has 3 horizontal tangents, and Grady already kind of made that connection. Like, that means a turning point in the graph, which means we could say, without ever graphing this, we know there are 3 turning points. We don't know which way they're turning yet, but we know that there are 3 at x equals 0 and x equals plus or minus 2. This isn't really worded very well. Where do they occur? Do you think we should find the y value that goes with those?
Nope.
We have time. We might as well. How do I ask your opinion when I already know the answer, right?
What is it?
At 0 comma something,
Oh,
at negative 2 comma something,
So,
and at 2 comma something. Where do I plug these back in to get the y values that go with them? Yeah. Into the derivative or into the original function?
original,
Yeah, if you plug these into the derivative, we're just going to get the slope. We should get 0 to plug them into the derivative. But I want to know the y value, that I could actually graph these max and mins if I found the y value that goes with it. So if I plug 0 into the original function, what do I get?
2.
That one's easy.
0 minus.
If I plug in negative 2 and positive 2, am I going to get the same answer?
Yes.
because it's even, right? See how this is a 4 and a 2 power? Like, I think it's going to be the same answer, so I'm just going to do it once. What's 2 to the 4? 16. 2 to the third is 8. 2 squared is 4 times 8 is minus 32 plus 2.
Negative 4.
Negative 14. It's going to be negative 14 for both of those. What we're going to get towards as we get through chapter 3 is we're going to be able to tell a whole lot from a graph just using its derivative. We can tell the high and low points. We can tell where it's increasing and decreasing.
Now we can tell the direction.
Now we can kind of figure out where it's going. If we just graph those two and maybe using what we know about end behavior, just doing that, we already know a lot. We have graphing calculators now that do all that for us in an instant, that graph it for us. A long time ago, this was really, really useful information because they didn't have the technology that we have now to graph all of that. How about that? All right, so very big day in calculus. And the rest of this week, tomorrow, we're going to learn the product rule and the quotient rule. How do we take derivatives of products and quotients? And then Wednesday, we're going to learn about what if we took the second derivative, and what if we took the third derivative? What happens then? Big, big week, so try to be here. And try to do your homework so you don't get behind. And I'm going to sing to you. I might even sing to you tomorrow
Today.
about the quotient rule. So this is homework 3-3 day 1. 1 through 12, all 25, 38, and 53. Definitely check your odd answers. Make sure you're doing this right. Yeah. And you actually have some time to work, so work on it so in case you get stuck, you can ask me for help.
I'm ready to take like a second or third, fourth.